Welcome everyone to the Machine Learning Overview section of the course. So it's finally time to dive deeper into machine learning. We've already learned a lot about the Python libraries available to us for data analysis, things like NumPy, Pandas, Jupyter Notebook, Seaborn, Matplotlib, and now what we're going to do is start shifting our focus into machine learning. And so this particular section on the machine learning overview is designed to help us get in the correct frame of mind for the paradigm shift to machine learning. So first, let's quickly review where we are in the machine learning pathway we discussed at the very start of the course. So recall that in this machine learning pathway, we start from the real world and either we have a problem to solve or a question to answer. So how do I fix or change X, or how does a change in X affect Y? And now what we're going to do is really focus on solving problems. And for this, we're probably going to need machine learning. So we're trying to build data products with machine learning instead of just performing data analysis like we just did in your capstone project. So we already know how to collect and store data, clean and organize data, and perform exploratory data analysis. Once we're able to do all that, we can begin to focus on machine learning models, both supervised learning, predicting an outcome, and unsupervised learning, discovering patterns in data. So pretty much the rest of the course is focusing on this section because there's so many algorithms that we can use for machine learning models. Now our main goals in this particular section of the course, where we're just calling this a machine learning overview, is to have a discussion on what types of problems are solved by machine learning. Why do we even use machine learning instead of just normal computer algorithms? Then we'll discuss the different types of machine learning that we cover in this course, what the difference between supervised learning is versus unsupervised learning, and then, since many of the algorithms that we start off with are supervised learning, we're going to have a deep dive discussion onto the general machine learning process for supervised learning. Then later on in the course, we'll shift to unsupervised learning and have a deeper discussion on that. But since we start with so many algorithms that are supervised learning, this particular machine learning overview section does a deep dive into supervised learning process. And then to cap it all off, we'll have a quick discussion on the companion book that goes throughout the machine learning algorithms. Keep in mind, in this particular section, there is no coding. It's purely a discussion on critically important ideas applied to machine learning problems. You should also keep in mind that many relevant topics will be discussed later on in the course as we discover them, including things like bias variance trade-off, overfitting versus underfitting, cross-validation, feature engineering, scikit-learn, performance metrics, and much more. Pretty much for the rest of the course, we're going to have these machine learning sections where we have a section for each type of algorithm. For example, we'll have a section for logistic regression, and another section for random forests or tree-based methods, another section for things like k-means clustering, and so on. And most of these sections are organized the exact same way. We have an intuition and mathematical theory discussion on the algorithm. We have an example code along of an application for the algorithm. We may have then discussions on expansions of the algorithms, maybe discussions on their hyperparameters or regularizations, or basically anything that's not covered in the very basics of implementing the algorithm. And then we'll test your skills of a project exercise and then go through the solution. The only exception for this workflow is the linear regression section, which is actually the very first section we introduce for machine learning. And because it's the very first section, what we do is we take advantage of that and have you slowly discover various ideas within machine learning. So what we're going to do is when you start learning about linear regression, we'll give you a very simple intuition and mathematical theory understanding behind linear regression, and we'll perform a simple linear regression. Then what we're going to do is we'll introduce scikit-learn and how we can utilize that machine learning library with Python to implement linear regression. And then we'll expand on linear regression by talking about regularization in general and how we can apply it to linear regression. And along the way, throughout the next sections, we'll discover additional machine learning topics. So really what we want to do is, as you're learning about linear regression, we want to give you the motivations behind various machine learning topics, such as understanding performance metrics, feature engineering, and cross-validations. So as we get better with machine learning, we're going to discover these ideas as we go along. So after all that, we'll revisit linear regression to combine everything that we've discovered already for machine learning ideas for a final project exercise. So the upcoming sections are kind of split into three separate parts, where we're going to have a quick introduction to linear regression, and then we'll take a step aside and talk about things like performance metrics, feature engineering, and cross-validation, then come back and cap it all off with a linear regression project. So the first couple of sections in the machine learning lectures, they're going to be slightly different, but after that, we'll start with the standardized version for every other algorithm. Okay, so let's go ahead and continue by starting to understand why we even use machine learning to begin with and the various use cases for it. I'll see you at the next lecture.